You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal.
And I'm Hattie's co-host George Morgan, Director of 1.5 Architecture.
This episode is brought to you in association with Danish roof light manufacturer Velux.
What has been very exciting, interesting and challenging in the last couple of years is to see how fast the supply chain is moving in to adapt to this new set of questions that they're getting. So certainly all the big contractors understand a lot more about their carbon story of the buildings, looking at driving the carbon out of all parts of the process, the supply chain, material suppliers and so on. So we've seen an absolute pivot to that in the last 2 years that's been eye-wateringly quick.
Today we're speaking to environmental engineer Patrick Bellew, founder of Atelier 10, a global consultancy in environmental building design. The practice's best-known projects include Google London at King's Cross, currently on site, Gardens by the Bay in Singapore, the Yale School of Forestry, Croon Hall, and the refurbishment of the National Theatre in London. Patrick started his practice in 1990. He was one of the founders of the UK Green Building Council in 2007, and for more than 15 years he taught at Yale University, a base from which he jump-started the American side of his practice. Atelier 10 now has 11 offices around the world. In this episode, Patrick explains that post-COVID best practice for ventilation rates in commercial offices has tripled, and he describes how this can be done while still controlling energy use. He also weighs in on the lightweight, heavyweight debate, advocating the importance of thermal mass and noting that if he were to design his own home, it would be thermally massive. Patrick, we're delighted to have you with us today. We're currently facing many crises related to planetary health. Climate breakdown is a wide-ranging threat producing deadly heat waves, such as we've experienced this summer. COVID, meanwhile, means ventilation in buildings has never been more critical. If we increase ventilation rates to provide more fresh air, how do we reconcile that with using less energy? And what's the best approach in a climate like the UK?
Hi Hattie, lovely to see you, and thank you very much for inviting me to be on the podcast. I think it's interesting that how much the industry is refocused on ventilation as a result of COVID. I can trace our sort of exploration of these ventilation issues right back to work we were doing in the late 90s in schools, because there was a real link found between attention span and attention deficit in classrooms, and demonstrating that mostly what happened in primary school classrooms is people kept the windows shut in order to conserve energy in a misguided desire to be energy efficient. And so the CO2 concentrations built up to kind of 1,200, 1,500, 1,700 parts per million by the afternoon. In the last 5 or 10 years, there's been the kind of well-building movement, and this initiated a lot by the World Building Institute, but through a lot of other sort of informed clients in the UK, started thinking more about what are the things that make a building healthy. A real push to understand how ventilation was impacting upon health and wellness. And so whilst the energy lobby was driving codes such like the BCO codes for ventilation in office buildings downwards with the good intent really of trying to save energy, there were contraindicators that were showing that this was actually making the buildings sicker, and you really needed to be thinking about driving ventilation back up again. And so with what we've seen in the last 10 years has been a sort of consistent change from literally doubling of fresh air rates into commercial buildings as the new norm, and actually many speculative office developers looking to outperform one another with fresh air rates being a new measure of good. And I think, as MEP engineers, we were partly guilty for driving the ventilation down in the first place because it was perceived to be a way of saving energy. And that gets to kind of the second part of your question. So how do you solve that? And what are the impacts? And I guess, the impacts are definitely an increase in the amount of energy used both to drive the air through the building, requiring you to recondition a bigger volume of air. The things that we do to counter that generally are the almost universal uptake in heat recovery in ventilation systems, where 20 years ago, we would only put heat recovery in by stealth. We just wouldn't tell people we were putting it in. We would just put it in and it didn't get noticed often. These days, it's, you can't not put it into a building. So you recover a lot of the energy from heat recovery. And then, using very high efficiency heat pumps these days, as we do on our mostly all electric buildings, the energy impacts are not that enormous of actually increasing ventilation rates as an overall part of the picture of energy use in building. The lighting loads, the vertical transportation loads will generally be higher than those ventilation loads.
So just to have an idea, say with the post-COVID situation, are you increasing ventilation by 10% or more? Can you give us an order of magnitude?
Yes, absolutely. I mean, I'm a little bit focused on commercial because that's where there tends to be the most criteria. I guess 15 years ago, we would have been talking around something like 8 litres per second per occupant in a building. And I'll put the occupancy at, say, 1 per 8. That amounts to 1 litre a second a square metre. It moved up through sort of 12 to 12 and then up to 16. And now most of our developments are looking at somewhere around 18 to 20 litres per second per person. So that's 3 times the amount of fresh air that we would have been putting in back in the days when we were trying to drive fresh air out of buildings. So, it's a big difference. And it is certainly seen, you're regarded as best in class, like someone like Google, when you're putting air in at that rate, because you will keep the CO2 concentrations well below probably about 700, 750 parts per million in the occupied space, whereas before it probably would have been at 1,000 or 1,100 parts per million.
So do you need much bigger ducts and plenums to do this?
Yes, is a simple answer. I mean, not much bigger, but you need them to be bigger. So if you were doing a system like a typical, say, a fan coil unit system in an office building, you would have a bigger supply air duct going and a bigger supply air system pushing the air to those fan coil units. We're tending to use more technically complicated and more energy efficient systems at the moment, with using a combination of underfloor air supply, which gives you the lowest age of air in the space because the air comes up from the floor. And we're taking a combination of radiant cooling and heating and underfloor air supply. But that's the definite direction of travel is towards, away from fans and coils and blown systems in ceilings towards much calmer radiant systems with air coming up from the floor. And I remember drawing a diagram of this for a project we were doing with Foster & Partners many years ago. And it must have been 20 years ago. We have a lovely diagram showing this should be the way forward. And finally, I think we're seeing that the market is moving in that direction, but it's taken a long time for the speculative market to pick it up.
So it probably makes you feel more comfortable in a space because you don't feel those currents of air as much if you're using more radiant approaches.
Yes, that's the intention. One of the things that's very strange about our world is that we tend to design to imagined criteria set by an organisation such as the British Council for Offices, and they set criteria that would always absorb the worst case. In effect, it's led to buildings being somewhat over-designed as we've moved away from big computers on desks and big computer rooms in office spaces, and everyone's gone connecting to the cloud and has much lighter, smaller devices. The BCO is recently sort of conducting a review of this, and that will drive the requirements for the building infrastructure down and allow us actually to use these much calmer types of air conditioning systems, which have lower capacity, but are in fact just fine.
Does a client like Google or any other of your top clients, would they entertain the idea of adaptive comfort, that you have to put a jumper on when it's a bit cooler?
Yes, I mean, we're talking with a lot of clients about this, and I think there's a recognition. I don't know if you've come across the principle of alesthesia, which is the principle, it's a kind of the pheromonic trigger in your body when you go to a slightly different state, whether it's warmer or cooler or whatever, some sort of climatic transition. And that's actually seems to be, it's a stimulant, and it makes you somehow feel better. And it's something that's been picked up by the likes of Google, who recognise that actually giving a slightly more dynamic environment and not requiring everything to be homogeneous is actually more stimulating and more enjoyable and makes for a better workplace. I wouldn't say that's become a universal thing in commercial office space yet. We're seeing it when we're working on, say, airport or museums and those types of spaces where you tend to grade the conditions down so that you only condition very tightly in key tactical areas, as it were. But for the most part, because office buildings are fairly blind to their tenure, when you design them, you can have a conversation around it, but I wouldn't say it's a universally accepted yet that that principle is applied. But certainly when we did that project, as you know well, of the World Wildlife Fund's headquarters down in Woking, there we were very much talking about it being a bit cooler in the winter and a bit warmer in the summer, and anticipating that people would adjust their clothing and their activities and come in T-shirt and shorts if it was a bit warm. And that allowed us to be much more radical in how we condition the spaces.
So natural ventilation is something that some practitioners and planning policies have latched onto as being generally a good thing. The new approved document F talks about trickle vents in commercial buildings. Natural ventilation sounds great, and night purge ventilation to release heat often makes a lot of sense. But for background ventilation, for air quality and to manage moisture, it's not always very effective and can waste a lot of heat. If it was called uncontrolled ventilation, it wouldn't sound as virtuous as natural ventilation. So when would you say it's appropriate and when would you say it's inappropriate?
That's a great question. I mean, it's funny how the UK architecture market, particularly in the commercial world, is not very well set up to do naturally ventilated buildings. When you compare what they do across the pond in Germany and Holland, the architecture is geared around environment, and you find buildings that are never more than, 14 or 15 metres window to window. And they're very deliberate that they have the natural ventilation working in the spring and the autumn, and then they revert to more controlled systems, so you haven't got uncontrolled ventilation when it's when the wind's blowing hard and it's freezing cold. You don't really want all of your heat flying out of the building, which I think is what you were alluding to. There's a couple of great examples of that approach. One is the very famous and very thoughtful Commerzbank building in Germany, which is, it's a big tower, but actually the plans are a series of rotating small office, narrow spaces around a central core. And they literally turn off all the central plant for 6 months of the year, and that's how they save energy. Now, if you build a big fat tower with a centre core and you just naturally ventilate around the edges, you still have to leave all the plant running for the core areas. The ventilation has to still run mechanically because you're just not going to get air more than, say, 8 or 10 metres away from a window. And so the CO2 concentrations go up and it's not great. So the first thing I think the UK industry needs to do, the architectural profession needs to do, is to pivot to more deliberate natural ventilation models or mixed mode models that actually work over the whole floor area, because you want to be able to pull that big switch, on the 1st of March and then, click it back on again when it starts getting hot. So the other example is, again, our WWF building in Woking, which is quite a deep plan, but it has a central air shafts and central roof vents that allow the heat out. And there, the occupants get a green light or a red light, and green light says open the windows because the mechanical vent is off. And then when the weather's not so good, or it's cold or it's too hot, we close the windows and allow the mechanical systems to take over. Now, the natural vent purists might say you can actually do the whole year without any kit. I find that with the types of, when one's trying to design buildings that you have to sign off for very large and flexible occupancy, we tend to need a bit more certainty than that. So we haven't done a huge number of fully naturally ventilated commercial buildings. For us, it's about doing the right thing at the right time of year and recognising that our climate is different at different times of year.
So, Patrick, tell us what you're doing at Google, at the Google headquarters. Can you give us the highlights of your approach?
Well, the Google headquarters has got a slightly different approach because the design of the spaces is a sort of big 2 and 3 story warehouse spaces with sort of mezzanine floors interspersed. So we have very large areas where we can't get radiant cooling overhead. So we ended up doing was a much larger. It's a proper displacement system rather than just supplying air under the floor. So we're putting in a much higher air change rate of air under the floor and displacing all the heat up out of the occupied zones up to the top where we remove it. So the actual strategy for venting the building is a true variable air volume displacement system. And we've worked really hard on the facades. The zigzag facade that you can see emerging on the design now it tends to point the main bit strips of glass to the northeast and northwest. So you minimise the solar gain, and then there's the sort of timber panels that face to the sun, reduce the amount of direct solar gain and glare that we're going to get inside the space. So those warehouse spaces that you see emerging as you walk up towards the building now are very highly sort of engineered to try and minimise the environmental requirements as much as possible. It's connected to the district heat network that Argent have put in across the whole site, which is gradually moving to an all-electric solution from a CHP solution. So we've got very efficient green energy. We've sort of looked at materiality particularly. It's an early example where we've tried to minimise the embodied carbon of floor slabs and so on. It's a concrete, then another concrete floor, and in between the suspended floors are in CLT, in timber, to reduce the embodied carbon impacts. It predates the work that we tend to be totally immersed in now, which is responding to the RIBA sustainability guides and the LETI guides around embodied carbon. So actually, because the building was designed 2016, 2017, and those guides didn't come out until 2019, 2020, we haven't actually done a complete embodied carbon measure. But I think what we were doing then was sort of early small steps to engage with supply chain to try and drive carbon out of the materials and to deliver a very complex building, which is sort of suspending over like a railway line and a service tunnel, so requiring some fairly complicated gymnastics to make it work. And air is all coming from the floor.
What about the challenge of upgrading MEP plant in existing buildings? What is the roadmap of measures that you consider when you're looking at that? I mean, retrofit is where it's at now.
Yes, I mean, these retrofits we kind of tend to classify them as light green, medium green and deep green. The really deep green refurbishments happen when a facade is life expired as well as the systems in the building. So the opportunities to make significant savings and reduce the size of the principal equipment come about when you take facades off and replace them with much higher performing glazing, particularly because modern glazing with modern coatings is effortlessly better than it was before. There's a great example project was the Yale School of Architecture, Paul Rudolph's building that we renovated. We were involved in the renovation with Charles Gwathmey a few years ago. And the facade wasn't quite life expired, but nearly was. But we were having real problems fitting in any kind of cooling into a building that was originally not conditioned and was deeply uncomfortable. And we identified really that if we switched out all of the glass, we could massively reduce the size of all the systems in the building, and then it would all work, and much more effortlessly and without huge amounts of energy going into it. And so the university raised additional funds to replace the facade. It would have needed replacing within 5 or 10 years anyway. So we recycled the facade and put in modern high-performance glazing, and then were able to use a very low-key radiant cooling system to make the retrofit work. So I would call that a deep green retrofit because it's doing everything from the skin to the buildings. The kind of lighter green ones that we're seeing are the first step is almost always to retrofit better lighting, because lighting energy loads surprisingly are still a massive part of building energy demand as other loads come down. So, using a lot more LED, trying to be smart about how you use it, so you don't just use downlight, you wash surfaces, you change the brightness of surfaces and things to make lighting that's kind of more, doesn't appear dim, but actually is using a lot less energy to do the same job. And then really the switch away from fossil fuels to all-electric systems is the real challenger. The main thing one has to watch with that, well, a couple of things. One is that heat pumps are much, much more dominant visually and acoustically than a boiler is, and we have to really work hard to avoid cluttering all our buildings like you see around sort of Europe and in Asia with just grey boxes hanging on the outside with fans in. I mean, the biggest disaster we can perpetuate on architecture and humanity is to turn all of our buildings and houses to have these horrible grey boxes sitting outside. I hate them. But technically the challenge with them is that the water temperatures that you get off those systems are much lower than you get with a gas boiler. So typically a gas boiler would feed water out at 70 or 80 degrees centigrade. Typically a heat pump, it's 45 or 50. And so you need bigger heat emitters, or you need to have underfloor heating. So if you're retrofitting a Victorian house, you probably can't keep your existing radiators without adding some supplementary way of emitting heat into the room because the radiator just doesn't get hot enough. The other thing that we really have to be wary of in terms of fuel poverty is if we move from gas and just put in direct electric heaters, which in carbon terms do give you a better result now that our grid has decarbonised so much. But in cost terms is still really significant. It was always the case that if you run an electric heater, it's going to cost you 3 or 4 times as much as running a gas boiler. That's still true. That hasn't changed. Maybe it's 2 or 3 times now because the gas is a bit more expensive. But we can't be building buildings that are all electric and just putting in electric panel heaters, in my humble opinion, particularly if they're older buildings, because you will just pay an absolute fortune and fuel poverty will become, which is already becoming a thing, will become a really big thing. Whereas a heat pump will give you 4 kilowatts of heat output for every 1 kilowatt of electricity you put in. So it actually is cheaper to run a heat pump than to run a gas boiler just now.
We're recording this episode following record-breaking temperatures of more than 40 degrees in the UK, and it's not the kind of weather we've traditionally been designing for in this country. There's been a lot of talk on Twitter about is this the end of the all-glass facade, or at least should it be, or the unshaded glass box house extension?
Yes.
I know you've been arguing for that for a long time. Do you see clients accepting that now?
Well, I think the new building regulations is going to drive them away from the all-glass building. Because, our work studying the new Part L, which came into force in mid of July, to literally in the last couple of weeks, is going to be extremely hard to get an all-glass box through the new regulations, which is a good thing. They've been gradually trying to drive that out for years. I'm going to get on my hobby horse. I can't understand. I know we don't see ourselves as being European anymore, but why is it the minute you step across the channel, every house, every office building has shades and shutters on the outside that deal with the sort of high temperature conditions? It seems absurd to me that we don't externally protect our buildings in some way. And particularly, so what we're doing, we're seeing happening in all these big housing blocks that are springing up everywhere is too much glass, single-sided, single aspect, west-facing buildings, and absolutely no way to make them comfortable without air conditioning. Well, actually, if they had shutters on the outside or shades on the outside, you would be a lot better off. Now, this is where the paradox starts to come in now, the paradox between operational energy and embodied energy, and the shift that we've seen just in the last 2 or 3 years, which is saying, it's better to spend, its operational carbon is actually solvable with green energy. So worry more about embodied carbon right now, because that's carbon now. It's our immediately emitted carbon. And actually that does take you back to simpler, flatter, duller facades, because you've got less aluminium, you haven't got shading system, you haven't got moving parts, all those sorts of things. So it does present a bit of a conundrum to all of us who've spent, well, as you say, more than 30 years trying to drive operational carbon down in buildings, to find that we're being kind of top-trumped by embodied carbon as the new big thing. And quite rightly. I mean, it's something we've been talking about for a long time. And credit to the RIBA and to Letty for kind of bringing it into a much sharper focus, so that it's basically everything that everyone's talking about right now.
So how much of a difference can urban greening make? Is it more than just trees giving shade?
I'm a pretty massive fan of urban greening. I've just come back from a week in Singapore, and when you see how that city compares to other cities in the region and how much more comfortable it is to be in as a result of its extraordinary focus on the green. They call it the city in a garden. The deliberate deployment of shade trees to protect both road surfaces and pavements and all over the city, so you can walk comfortably despite the temperature and the humidity. And it is definitely cooler in Singapore than it is in surrounding cities because of their focus on this absorption by trees. Now, I think the figures are something like 60% of solar energy hitting a tree is converted into photosynthetic energy and isn't delivered as heat. Whereas if you have sunlight hitting a black road, 100% of that energy will be absorbed, re-radiated, maybe 90%, will be absorbed and re-radiated as heat at low level. And that immediately gives you this urban heat island effect. We do a lot of work on health and wellness and biophilia and those things, and I think that also is another part of the kind of the mental health story, and the sort of health and healthy, happy places is definitely to do with gardens and greenness and vegetation.
Thermal mass is often advocated to fight overheating. But if you've got bedrooms exposed to a lot of thermal mass, they're radiating heat when you're trying to sleep. So is this approach less suited to residential buildings than to commercial or public ones?
I've had lots of debate about this with people down the years, and I'm not... I think it can go both ways. I think I have seen some examples of sort of super thermally massive buildings, and they work really well. The attenuation you get works really well to minimise the energy demands. I think if you just talk about building bedrooms with the sort of concrete surfaces, thin concrete surfaces, I think you're right. You get an issue that you can't, for example, night cool bedrooms very easily because you can't really leave the windows open in a big way to drop the temperature too much at night. It's quite hard to demonstrate in residential schemes that you're going to achieve a huge savings or anything of energy use by the application of thermal mass. It's almost always about the insulation of your windows and the insulation in the walls that actually drive the energy performance and the ventilation. I guess the answer to your question is you can build a really good building that's very heavy, that will do pretty well, almost no energy, and you can build a really good building that's sort of super light with lots and lots of insulation that has a similar outcome. I personally like the more thermal mass approach. I made a bit of a career choice to pursue thermal mass as one of our sort of main topics of interest around sort of the labyrinths and things that we build. And I'm a firm believer that the way that thermal mass attenuates the day and the nighttime temperatures and sort of helps you to average out the weather is the way we should be designing. But I wouldn't say it's a universal truth in the UK, because I think you can design good lightweight buildings that have similar energy performance. I would say the comfort's probably better in a heavy one, but that would be my choice. So if I was designing my house in the future, my passive house, it would almost certainly be a high thermal mass with insulation as well, but highly thermally massive, because I feel like it's the right thing to do in our climate. But it does use a lot of material.
I was going to ask about the whole life carbon approach, because I know you've worked so much with labyrinths and are a big advocate of thermal mass. Is this still the way to go? Maybe in your own house, that's one thing, but on a very large project where you have big embodied impacts from these labyrinths?
Yeah, I mean, the labyrinths, it's been a question we've been asking right back to sort of Federation Square about the embodied carbon in those. We are increasingly looking at cement replacement alternatives for labyrinth structures. Tend not to be particularly structural. They're just a big lump of mass. It could be a big load of rocks in gabion baskets. It doesn't have to be concrete. It could be, it just needs to be something that's heavy. So we've done studies of sort of using of rock stores, which is another way of doing it. We're also looking with materials like sem-free, and in America there's a carbon absorbing concrete as well. The problem with some of these materials is that they're not good for strength. We don't really have enough data on longevity and strength to use them maybe as full structural materials. But when we're using them for infill or for just as a very simple panel like a labyrinth panel, they're perfectly viable, and you're not worried about curing times and all that sort of thing. So we're finding alternative materials for the labyrinths we're looking at the moment, which aren't as carbon intensive. And it's actually reflective of the whole industry starting to focus on this embodied carbon question. We've always known we have to do that, but I think we're just being much more deliberate about it these days.
So is Atelier 10 offering specific services in this area? Because I know structural engineers are really on it, and I've been talking a lot more to structural engineers recently. How do you feed into that?
I mean, in most of the projects that we're doing, we act as the kind of consolidator of everybody's information to run the whole building carbon model. So the structural engineers generally they feed in the superstructure data. They help us, or we help them. We challenge them to look at different solutions. We look at different column grids, really working to drive the carbon out of the basic scheme. And our structural friends have adapted really fast to this and producing some amazing sort of data now out of their models to allow you to really compare and contrast alternatives through the lens of carbon rather than anything else. What has been very exciting, interesting, and challenging in the last couple of years is to see how fast the supply chain is moving in to adapt to this new set of questions that they're getting. So certainly all the big contractors now are far more deliberate about how they and understand a lot more about their carbon story of the buildings. looking at driving the carbon out of all parts of the process, the supply chain, materials suppliers, and so on. So we've seen an absolute pivot to that in the last 2 years that's been eye-wateringly quick. And then we're starting to see all the steel and aluminium suppliers and the glazing suppliers and the facade suppliers and all of the people involved really trying to look as to how to retain competitive advantage by having the best story around carbon, because nearly all tender bids they're doing will have questions around carbon. But I think the minute you start to make all the cement manufacturers and all the steel manufacturers really care about this subject, you really come back to sustainability and competitive advantage and the value conversation, which is significantly different to the previous 26 years of my career in Atelier 10, where it was an uphill struggle a lot often to have these conversations, and now 70% of design team meetings are absorbed with carbon. It's extraordinary how it's changed. A lot of our clients see that they need to be, if they're not offering the greenest, the best, the most highest performing buildings, then any of the potential occupiers who has an ESG commitment will be asking the question about their performance and doing a comparison on different buildings, and maybe now finally picking the best one, whereas for years and years and years no one really gave a good goddamn whether a building had an EPC B or a D. It wouldn't really make any difference.
Do you ever say no to projects? I noticed when I clicked on your website last night that the first project that came up was Safdie Architects' Jewel Changi Airport in Singapore.
Are you suggesting that's not a very green project? Yeah, I mean, we took the environmental design of that project on because we were aware from Gardens by the Bay what the impacts of waterfalls were on building performance, or on systems performance. And so a lot of the work we did at Changi was to try and minimise the impacts of the big waterfall that was part of the big idea that predated any concerns about carbon emissions. So there's a lot of hidden environmental work in that big bling building. But it doesn't answer your fundamental question, do we ever turn work away? And the answer to that is yes, we do. We normally try and analyse whether we can make an impact, whether we feel that if we're doubtful about what the building is being used for or the provenance of the brief or whatever, we want to know is, can we make an impact? Can we make it better? Is the client open to a conversation around innovation and ideas? And that will sometimes tip us towards taking on projects that maybe would look a bit, you might look at afterwards and go, why did they do that? But yeah, we turn away. I don't want to name sectors or names, but we turn away certain types of work, or we don't take up certain types of work just because we feel that there's not seriousness around trying to do things better. You can imagine we have a lot of conversations, particularly around aviation, and at the moment we still are involved in airport projects and in developing new terminals, buildings in a number of locations with world-class architects. But again, most of that's driven by how do we make them more environmental. We see it maybe wrongly, but the aircraft manufacturers are dealing with the carbon issues of the fuels and all those sorts of things, and we're trying to deal with the building owners to make better buildings. And so if we turn everything away on the grounds that it's going to involve carbon emissions, then we will have nothing to do and the buildings won't get any better.
That touches on the idea of sort of the boundaries of what you're kind of considering when we try and develop sustainable buildings. So a net zero carbon building in whole life carbon terms means that the building plus an offsetting scheme elsewhere adds up to zero over 60 or so years. So it's about projects individually getting to zero rather than society as a whole getting there. What do you think of that approach? Do you think there are unintended consequences?
I think one of the concerns about the ready acceptance of offsetting as an alternative to pushing harder is that actually buying carbon offsets is still a bit too cheap. And so there is an easy way out on some projects from actually doing better in the building to handing it over to the bigger ecosystem, if you like, to solve the problem. So I definitely think the unintended consequences of this could well be that we sort of run out of good things to do. I think as yet, there's plenty of good things to do to improve kind of global CO2. And I mean, for me particularly, it's investment in wind, it's investment in remote solar installations to avoid emerging nations from having to, where they've usually got a lot of sunshine, but their climates are aridifying. They've got issues with, they can't pump water to irrigate and so on and so on. So there are things that we can do here. There are plenty of problems to solve through offsets. So I'm not against offsets per se. But I do think there is a risk that we start to oversimplify design on the basis that we just offset our badness. You get the counter result when you plant 1 million trees in California as your offset, and then they all become fodder for a forest fire. That can be an unintended consequence that you don't want to read about if you're a big American corporation who recently had that problem.
There's one question we missed out earlier while we were talking about thermal mass. I wanted to get your take on the proliferation of the use of CLT in buildings now. Do you see that as a promising way forward?
But I personally feel that the use of CLT and use of timber in buildings in appropriate locations and in increasing locations is a good thing. I slightly worry that not everybody can build everything in timber. We don't have enough, clearly. So I don't think it should become a universal placebo. And I don't think it will. I think our fire codes and things here are going to stop us from building as tall as we might like to or as big. But I do really enjoy the conversation that it brings to almost all design meetings as to how to incorporate appropriate amounts of timber into buildings to try and minimise the impacts of concrete and steel. And I came from a meeting this morning where we were looking at a pretty stressed concrete slab building, but with large drop-in panels of off-site fabricated CLT as infill and knockout. And it gives not only an interesting solution, but it gives a much lower carbon structure without using sort of crazy amounts of timber. It just solves that problem. So I think when it's appropriate, I think it's a great material.
Atelier 10 has offices in the UK, the US, Singapore, Australia. Do sustainability concerns vary in these different places?
Yes, it absolutely. People have really different concerns across the world. The markets are so different. It's quite surprising. So moving from kind of west to east, in California, incredibly interested in. They're very, very absorbed by climate change. They're the forest fires and they're sort of all their weather systems are changing, and so they are totally focused on both operational and embodied carbon. So the work we've done with Thomas Heatherwick and Bjarke Ingels Group on the Google headquarters down in Mountain View, which recently opened, the biggest ground array heat pump in America. And we have some, I think, like 7 megawatt power station on the roof with interlocking PV tiles. So that's at that extreme, there's a big moves in the West in California. In New York, tends to be much more focused on adaptive retrofit. Really, because of New York statutes, every building is required to reduce its carbon emissions or get fined by 2030, I think it is. So massive focus on deep green retrofit, as well as some very interesting new build master plans, lots of university campuses and laboratories and things. Asia is just starting to come around to the need for them to have a care. It's taken a lot longer in Asia. We've got pockets of interest, but it's been quite tough to get sustainability as a thing out there because they struggle with the heat and the humidity, and they're just used to air conditioning things, and that's kind of what happens.
And I also wanted to ask you, what does regenerative design mean to you? Is this just another buzzword, or does it connote a new way of working going forward that resonates with you?
It's one of the things we do a lot of. I personally do a lot of projects in central London, and so it's much more difficult to see the opportunities for regenerative design. It's hard to, on individual building sites often, to see how that can really play out, except by becoming part of a bigger market. We're talking a lot on projects now about, when you deconstruct a building, how can you share the materials around to other projects where they might benefit it, even if you can't use the material on site. And we're starting to see new agencies emerging who act as a kind of trading for deconstructed materials. It's no longer just fancy Victorian assets that are being recycled. It's pretty crude stuff like cladding and glass and all that sort of thing. So, the conversations rage around this subject. We don't always find a way to deliver it, but we do very much see these conversations going on.
So what have you got in the pipeline at the moment that you can tell us about?
We are working on a lot of commercial real estate around London, actually, surprisingly. Our market here in London is very dominated by some significant buildings, beyond the Google building. We're working on a number of big projects for British Land, for Brockton, for various other developers.
Are they new build or retrofit?
All kinds of things. I should add, actually, to that list some really interesting projects with the likes of Fabrics, emerging developers. Tyler Goodwin at Seaforth Land restoring Space House, the Seafoot building down on Kingsway. Really exciting kind of deep green refurbishment of that building, which is a challenging building. So we've got some great projects. Some of them are new builds, some of them are complete retrofit. Some of them are, quite a lot these days, are a mixture of retrofit on the lower floors and then building new things above. We're working on a project with Eden right now, which again is top secret, so I can't tell you too much about it. And also involved in a number of projects in the Middle East where there's a real push to build net zero buildings. We've recently finished the Bihar building with Zaha Hadid Architects in Sharjah, which is a very beautiful office building, one of the last projects that Zaha was working on before she passed away. And we're hoping to kind of continue working out there with that team to do some really interesting new work that, again, is top secret, but there's some opportunities there to really exploit solar energy and energy storage.
Great. Well, thank you so much, Patrick. It's always great to catch up with you. In our next episode, we'll be returning to our focus on architectural education, speaking to two guests. Sophie Pelsmakers about her new book, Designing for the Climate Emergency, a guide for architecture students, and structural engineer Kiran Malik, who has recently taught as a technical tutor in 7 different schools of architecture. You can find the show notes for this episode at www.architectsjournal.co.uk/podcasts, where you can also catch up with all our previous episodes. If you're enjoying Climate Champions, please subscribe and do rate us on your favorite podcast platform. It helps people find us. Thanks.